Polar character of covalent bond. Covalent bond is formed when two atoms having similar or almost similar electronegativities, fill in the blank question, share equal number of electrons, that is a second condition, same or equal electronegativity and share equal number of electrons. This is the ideal situation for the formation of a covalent bond between the combining atoms. When the values of electronegativity of the two combining atoms are equal or almost equal, the bond formed between them is almost a pure covalent bond. Condition for a pure covalent bond. However, the formation of a covalent bond is also possible between two dissimilar atoms possessing different values of electronegativity. Case 2. That means either it is similar or almost similar, or second case is there is a different values of electronegativity. In such cases, the covalent bond is not pure and contains some ionic character or polarity. Partial ionic character in covalent bond. Electronegativity is the measure of the tendency of an atom to pull the shared pair of electrons towards its own side in a covalent bond. When a covalent bond is formed between two similar atoms, the atoms having the same values of electronegativity, and the pull of the two atoms shared pair is equal, and the shared pair lies just in the midst of the nuclei of the two atoms. This is called non-polar covalent bond. For example, hydrogen and hydrogen, same electronegativity. Therefore, the electrons in the middle, nothing will happen. It can remain as such. Whereas if another atom with high electronegativity, this electron will be shifted towards it. That is what we are going to discuss. Now, non-polar covalent bonds are hydrogen, chlorine, oxygen, nitrogen, fluorine, bromine, etc. That means both are having the same electronegativity. Therefore, an electron cloud is formed between the center, and both are having equal. Therefore, no question of shifting the electron towards one atom. When the covalent bond formed between two atoms of different electronegativities, the situation changes. The atom with the higher value of electronegativity tries to pull the shared pair to a greater extent as compared to the atom with a lower value of electronegativity of atom. The electron cloud constituting the covalent bond is no longer symmetrical around the two atoms and gets distorted. Just for example, A and B. B is highly electronegative. Therefore, the shared pair of electron will be shifted towards B. That is what it is shown in the diagram. Therefore, the electron cloud also, the side of B, it is shown darker side, showing that high electron cloud. This can also be represented by partial positive charge for A and partial negative charge for B, because the electron is shifted towards B. The cloud is more dense around the more electronegative atom as shown. On account of this, more electronegative atom acquires a partial negative charge represented by delta minus, and less electronegative atom acquires a partial positive charge delta plus. The covalent bond thus develops a partial ionic character. Such a covalent bond is referred as polar covalent bond or partially ionic covalent bond, and the molecules possessing such bonds are known as polar covalent molecules. Give one word or choose the correct answers or correct the statements. All this type of questions can be asked from this section. Or simply polar molecules. For example, hydrogen fluoride is a polar molecule. In hydrogen fluoride, the bond between hydrogen and fluorine, the bond is a polar covalent bond due to unequal sharing of electron between the two, more electronegative fluorine and less electronegative hydrogen atom. Consider hydrogen fluoride. A bond is formed between hydrogen and fluoride by sharing a pair of electrons. Because fluorine is highly electronegative, fluorine attracts this shared pair electron towards its side. Thereby, the full electrons are on the fluorine side. This causes a partial positive charge for hydrogen because it lost the electron towards the fluorine atom. The fluorine gained hydrogen's electron also. Therefore, fluorine gains a partial negative charge. A molecule having partial positive and negative charges separated by a distance known as bond distance and is also referred to as a dipole, that is having two poles, that is positive and negative pole. Therefore, it is known as dipole.